There's so many videos on YouTube about setting up cheap speed controllers and so many misleading videos on what's going on with this controller board, which is so common to so many treadmills. I thought I would just have a look at this and work it out properly, instead of pointing at a resistor and calling it a diode. There it is, R63, 0.01 ohms, 1%, written on it. So this is my contribution to it. I've wired it up, 240 volts, comes into the board here. The earth goes over to this earth point. This is the harness to the main screen. Has all the controls on it. Ground, 9 volts, tacho, PWM, incline up, incline down, incline sense maybe, ground, and the next 3 pins there are for the incline actuator. Test points, these 2 here are for the tacho. The LG5 and 6 are the positive and negative out to the 130 volt DC treadmill motor. Today I've just got it hooked up to a 240 volt incandescent globe, pattern holder, so that we can see what's going on. I've got my multimeter there, and I've got a little digital scope here to have a look and see if we can work out what's going on. This thing here is the little breakaway cut-off switch. Connect this end of it to your belt or your clothing or your wrist, and if you get out of control and fall off, pulls it out and shuts the machine down. First up, we'll measure the AC input, 235.5 volts AC. Alright, DC volts, ground should be 9 volts out onto the front panel display, 9.07 volts. Power out to the motor, 0 volts. I've just got to put a load on there, and just to see what the power out's doing, give us a visual indication without having to set up the motor. Alright, start. It's set for 2 kilometers per hour. Oh yeah, we've got a very low pulsed DC output around about 12 volts, 11 to 14 volts. So it's pulsing. I can see the red light flashing on the power board, controller board. Let's go up a little bit. Let's go a bit higher. So 14 on the scale, 14 kilometers per hour. It's telling us, set our range manually here to 600 volts. And I'll put in max 111.3 volts, 117. So we're close to 100. It's probably 120 volts thereabouts. The multimeter's not fast enough to capture the quick peaks. Okay, let's go up to 22 kilometers per hour. So the pulse rate hasn't increased. I can see voltages up to 154 there, I think. Okay, maximum 183 volts. So this is pulsed into a 130 volt DC motor. Seems like it would work for a 180 volt motor as well. Let's have a look with the little scope. Come back down to 2. 9 volt channel, 9 volt rail here. Getting some, should see 9 volts in there. That's a pretty noisy 9 volts. What do I got going on here? Okay, so the scope was picking up a whole lot of noise, 50 hertz noise. I put some earth wires to ground the systems. What I'm interested in here, so PWM. At the moment, there's nothing on it. We've got 20 milliseconds per division. 25% Dutycycle at 2. Let's go to 10. I wonder if we'll see about 50% Dutycycle. So it's close, it's probably 45%. We'll go right up to 22 kilometers per hour. And the pulse width is now around about 85%, something like that. I'm surprised by the pulse rate of the power to the motor. And I wonder if I put the motor on there whether we'll see the same thing, so that will be the next test. But it looks like we could use this board speed controller using a 1 volt peak to peak pulse width modulated signal in onto the dark blue wire, and the 9 volts out. It's got plenty of power, it can drive this whole display system here, audio and fan. You might see when the motor's on that it's just pulsed in this way as well. Might not matter with the flywheel and the treadmill setup, but I'm a little bit surprised by the spacing of the pulses for the motor. Let's see what we get next. Okay, so I've set up again exactly the same as it was on the bench, except instead of the light globe I've got the original motor. The belt is disconnected. Let's fire it up and watch the volts on the meter. 2 kilometers per hour. There goes the motor starting. Volts is 10 volts. I'm going to put my hand on the flywheel, see if I can feel that pulsing that we saw in the light globe. There's definitely a pulse there. I can feel it in the iron bar across the back, the steel bar that the motor mounts to. Slight vibration, and I can hear the motor load changing. It's about 1 hertz. Nowhere near as obvious as it was with the light globe. Let's go up a bit. 8. Definitely hear the motor start up with the pulsing. 22. We're sitting at 146 volts. Motor's still cranking. And there's that 85% Dutycycle that we saw earlier. About 1 volt peak to peak. So I've just done a quick Arduino sketch which takes 9 volts V in, ground, the PWM output is the blue one there from the Arduino. The Arduino is setting the PWM based on the position of this pot. We'll set the pot in the middle, power it up, make sure the Arduino doesn't smoke, and measure the output on the board without the motor connected. 15 volts. We could put the globe on if we wanted to. Adjusting the pot is not making any difference on the voltage output. So we've obviously not got this right. Let's have a look with the little scope, see what the output is. I've lost the little oscilloscope to determine the output frequency of the PWM. Without the scope, we can put the multimeter onto hertz. It's 20 hertz. So 20 hertz, I need to set that in code, 50 milliseconds for a full wave. Okay, 10 milliseconds to 40 milliseconds for a 50 millisecond full cycle. Let's plug it in, let's see if we can blow something up. Let's have a look at the output frequency, the PWM. Pin 3 is the output on the blue. So 19.95 hertz. We'll see what happens with that. It's pretty close to 20 hertz. We'll see what happens. You'll see the Dutycycle there. Rotate this thing slower and faster. So that's around about 35%, 40% Dutycycle. Slowing down at around about 20% and quite high at around 75%, 70% Dutycycle there, at 100 volts on the meter. Still getting the pulsing at around about 2 hertz. This literally is all you need to use the existing power module from a treadmill to run a treadmill motor. This is a $4 or $5 Arduino Nano, Chinese knockoff version. This is a 100k pot, anything from 5 to 100k would be fine. So we're talking $5, and the only other cheaper way to do it would be to use the existing control panel, but nobody wants that on their shed wall. So yeah, that's another alternative. However, having gone through all that, I don't like the way this controller and power module drives the motor. I don't like the pulsed output, so I think that we'll give Trevor's SCR version a go, and it looks like that is a very useful, versatile and cheap option as well. Initially I wanted to try and reuse the old parts to minimize waste, and I have these and I don't have the SCR, so that was the start of it. Then I needed to understand better, so that's why I went through the process. Very skeptical about some of the information available on YouTube. Happy to answer any genuine questions about it, but in all honesty, I think this is not the way to do it.